an upward or downward motion in vertical plane termed as vertical motion. A free fall vertical motion is the motion in a vertical plane under gravity. It is a uniform accelerated motion. In this session, you would be learning how you can find out different parameters related to vertical motion, like velocity of throw, maximum height, or time of the flight, etc., using equations of motion in most easy and interactive way. Motion upward or downward in vertical plane termed as vertical motion. The motion of an object under the influence of gravitational force is an example of vertical motion under gravity. When no force other than that gravitational force acts on an object accelerates toward the Earth's center with a constant acceleration. The value of this acceleration is z, which is equal to 9.8 meter per second square. And the motion is termed as free fall motion or uniformly accelerated vertical motion under gravity. We know that any uniformly accelerated motion can be analyzed using the 5 equations of motion. Here are those 5 equations of motion. To know more about these equations, you can check out our video on equations of motion. Link to this video you can see on the right top corner in iCard. You can find the link in our description box as well. Equations of motions are vector equations. Vectors have magnitude as well as direction. In case of vertical straight line motion, motion can have only 2 directions, the upward direction or downward direction. So to present linear vector quantities, we can use positive and negative sign to present these 2 directions. As per the Cartesian coordinate system, we generally take upward direction as positive and the downward direction as negative. Now, out of these 5 variables used in these equations, u, v, a, s and t, 4 are vectors. Time t is a scalar quantity. So, for upward direction, we take all these four variables as a positive, and for downward direction, these 4 variables has negative value. Since the acceleration due to gravity is always in a downward direction, so it is always negative. The magnitude of this acceleration is constant near the Earth's surface and it is represented by z. So here a is equal to minus z and which is equal to minus 9.8 meter per second square. Remember, it is always in downward negative direction irrespective of direction of motion. Now let's take different scenarios of free fall vertical motion and see how we can use the equations of motion to find out the different parameters. So mainly the vertical motion have 3 different type of problems. The first one is like dropping a ball from a high rise building or throwing a ball in vertical downward direction with some initial velocity. Another type of case, a ball is thrown from the ground to upward direction and it will come back to the ground. In third type of scenario, the ball is thrown from a height, from a cliff, and it goes downward to the ground or in the sea. Now let's take few practical problems. So a ball is dropped from the roof of a building. It takes 5 seconds to reach the ground. What is the height of the building and what is the velocity just before it hits the ground? So here what we know, a ball is dropped means we know the initial velocity u is equal to 0 and from roof of a building it takes 5 seconds to reach the ground. So time t is 5 seconds. What else we know? The acceleration, because this motion is under gravity. So acceleration a is minus g, which is equal to minus 9.8 meter per second square. And what we need to find out? We need to find out the height h of the building or displacement and the final velocity, the v, just before it touching the ground. Now we know the equations of motions. Here we have these three variables, u, the time t, and the acceleration a. And we need to find out the displacement or height of the building. So to find out the fourth variable, which is s, I think this is the third equation is most suitable, right? Because we know the three parameters and the unknown value of s we can find out using the equation number 3. So let's put the values. S equal to u is 0, so this is 0, plus half a is minus 9.8 into t square. T is 5, so 5 is square. And this become 9.8 negative divided by 2 multiplied by 25. Okay. If you solve this, then s become minus 122.5 meters. So that is displacement of the ball is 122.5 meters in negative direction or downward direction. And this is nothing but the height of the building. The height of the building is 122.5 meters. The second part of the problem is to find out the final velocity, right? So to find the final velocity, we have now 4 parameters. If you see u, t, a and s, so we can find out the final velocity by using different equations, right? So if we use the first equation, let's take v equal to u is 0, which is this one, 0, minus a is minus 9.8 meter per second square, multiplied by time, which is 5 seconds. So this become 49 meters per second. So this is your negative, here negative sign. So velocity is 49 meter per second in downward direction. Now let's take a variation of the same problem. In this problem, we have the height of the building already given, and we need to find out how much time does it take to reach the ground and what is the speed just before it hits the ground, similar to the problem 1a. Okay. So what is given here? The ball is dropped. So it means the initial velocity u is equal to 0, and the height, which is the height of the building h, which is 122.5 meters. That means the displacement is in negative direction, because motion is in negative direction. So displacement is negative 122.5 meter. And we know the acceleration here minus g, which is minus 9.8 meter per second square, right? So we have again 3 variables, u, the displacement and the acceleration. Now what we need to find out? We need to find out the time, right? The time t and the final velocity v, right? So we have our 5 equations of motion. So to find out the time, we have to check u, s in a and t. Which equation contains these 4 variables, u, a, s and t? Here equation number 3. So if we use equation number 3 and put the values, s equal to minus 120.5 meters equal to ut, u is 0, so ut is 0, half at square, so plus half, a is minus 9.8, t square, t is we have to find out. So this become t square equal to, here minus minus sign will cancel out, right? So it will be become 122.5 multiplied by 2 divided by 9.8. Okay. So if you solve this equation, you will get t square equal to 25, and this become t is equal to plus minus 5. Since time is a scalar and cannot be negative, So it's a 5 second. Okay, so this is your answer. And if you see the time taken by this flight is 5 seconds, similar to the whatever we have in problem number 1a, right? In that problem the time was given 5 seconds and we got the height of the building as a 120.5. In this problem, which is a just extension of the same problem, here we already have the height and we got the time. The second part of the problem is to find out the speed, not the velocity. Understand, this is, they are asking speed instead of velocity. So speed is nothing but the magnitude of velocity. So we will find out the velocity and then we can give the value of speed from there. To find out the final velocity, we can use the equation v is equal to u plus at. So here u is 0, which is from here, and a is minus 9.8 and t is 5 seconds. So this become negative 49 meter per second. Negative means it's in downward direction. The velocity is in downward direction. So speed at the moment when it is going to touch the ground is 49 meter per second, and this is your answer. Now let's take another type of problem in which a ball is thrown vertically upward from the ground at a speed of 98 meter per second. And what is the maximum height it reaches? How long does it take to reach this height or time of ascent? What is the time of descent? And what is the total time of flight? And at what velocity does it return to the ground? There may be multiple questions on this flight, okay, like few of the questions we are talking about here. The only important point is we need to know what is given in this problem and what we need to find and which equation of motion is suitable to find out the unknown value. Okay, so let's do this one. Here a ball is thrown vertically upward from the ground at a speed of 98 meter per second. It means the initial velocity is 98 meter per second. What we know other thing is the acceleration, which is always negative, right? Negative g or negative 9.8 meter per second square. Let's attempt the question number 1 here. Okay, what is the maximum height it reaches? So that means we have to find out the h, the maximum height, or we can say the displacement s, right, or maximum displacement. Now we have equations of motions. Here we have 3 variables, u, acceleration a, and unknown variable maximum height. But we should have one more variable to know the unknown. So since we are talking about the maximum height, that means at that moment the velocity of the ball will be 0. So final velocity at that moment is 0. So we know the third variable value. Okay, now we can find out the maximum displacement or maximum height the ball reaches. And here we can use the equation which is most suitable is this one. So by putting values there, v square means 0 square equal to u square 98 into 98, right, plus 2a is minus 9.8 meter per second square multiplied by unknown value s, which is s maximum, you can say. So rearranging this, the s will be 98 into 98 divided by 9.8 into 2, and this will be, this become 10, this is 49, so this become 490 meters, and this is positive value. So there is a maximum displacement is 490 meters in positive direction. So let's attempt this part number 2. Okay, how long does it take to reach the height? So time of ascent. Here again let's put whatever we know. The maximum height which we just calculated in the previous part is 490 meter, right? And A is minus 9.8 meter per second square. Now we have to find out the time of ascent. You can say TA. Again look for the most suitable equation of motion to find out the time. So we know V, we know U, we know A, acceleration, and we need to find out the time. So equation number 1. Okay. So here if you put the values, V is equal to 0, equal to U is 98 minus 9.8 into TA. It means TA is equal to 10 seconds. So the time taken by the ball to reach the highest point is 10 seconds. Now the next part of the question is, what's the time of descent? How much time the ball will take to come down from the highest point? Remember, in gravitational, when the motion is under gravity, this time is same as the time of ascent. Okay, we can check this by finding out by using the equations of motion. Let's see. So now we will check this particular problem from the perspective of when ball is dropped from the highest point. In that case, the initial velocity is 0, right? And the acceleration is same as a minus 9.8 meter per second square. The displacement is S maximum because it's coming from highest point to the now lowest point, the ground. So displacement S is minus 490 meter because it is in now negative direction. So we know these three variables, and what we need to find out? The time of descent. Here we have three variables, known variables: 1 acceleration, displacement, and we need to find out the time. So equation number 3 is the most suitable equation. Now put the value of these variables. So displacement S is equal to minus 490 meters, equal to U is 0, so UT is 0, plus half minus 9.8 into TD square. So this says TD will be 2 into 490 divided by 9.8. So TD is 10 seconds. You see, the value, time of ascent and time of descent is same. So another part of this problem asking for the total time of the flight, which is nothing but the summation of time of ascent plus time of descent. So time of flight will be 20 seconds. So your answer is time of descent, time of flight. Now the last part of the problem is related to what velocity does it return to the ground. So here we will write down whatever information we already have. 98 meter per second. Acceleration we know minus 9.8 meter per second square. And displacement when it come back to the ground can be taken as 0 now, because the ball has came back to the same point. And now we have to find out the velocity. Okay. So we know the three variables, the U, A, S, and we need to find out V. So the most suitable equation is the fourth one. So using this equation, let's put the value. So V square is equal to, U square is 98 into 98, 2AS minus 2 because A's value is negative, which is 9.8, into S, and S is 0. So V square equal to 98 square, or V square is equal to plus minus 98. And we know because this motion is in downward now, so velocity is minus 98 meter per second. You see, the magnitude of this velocity when ball returned back to the ground is same as the velocity at which this ball was thrown upward direction. Now let's take the last problem. A stone is thrown vertically upward at 49 meters per second from a 117.6 meter cliff above the sea level. What is the maximum height attained by the stone with respect to the sea level? Okay. Maximum height means from sea level means we are talking about this height. Another point is how long will it take to hit the water, and what is the velocity and speed at the time when it hits the water. How far will the stone travel just before hitting the water, and what is the displacement. So many questions can be created from this motion. Now let's do these one by one. Okay. Here what is given? The stone thrown vertically upward. That means the initial velocity is given plus 49 meters per second. From a 117.6 meter cliff above the sea level, which is this one. The initial height from where it was thrown. What is the maximum height attained by the stone with respect to sea level? The first part of this problem. Maximum height. When we talk about the maximum height, that means we are talking about when the velocity of the ball is 0 and it is start coming back. So here the maximum displacement as maximum we have to find. At this point we know the velocity is 0 meter per second. And the third variable which we already know is the acceleration, which is minus 9.8 meter per second square. So now we have three variables which is known: the initial velocity, final velocity and acceleration. We have to find out the displacement. Now let's check the motion equations. Which equation is the most suitable? So by looking into variable, we can say our most suitable equation is this. So here the v is 0, so v square is 0, u square is 49 into 49 meter, minus 2 into 9.8 into S maximum. So S maximum equal to 49 into 49 divided by 2 into 9.8. Okay. And if you solve this become 98, so this become 2 into 10, right? So 490 divided by 4, 490 divided by 4, so this will become 122.5 meter. It goes to maximum height of 122.5 meter from this cliff. Okay. Now what is question is asking? The maximum height attained by the stone with respect to sea level. So we need to add this height as well. So what is the maximum height here from sea level? It will be 117.6 plus 122.5, 240.1 meter. So that is what S maximum. Now let's take the part 2 of this question. How long will it take to hit the water? So here the initial velocity is u, which is 49 meters per second. The acceleration is minus 9.8 meter per second square, and the displacement S for this complete motion is minus 117.6 meter, which is this distance. Okay. So and we need to find out the time to hit the water, right? So here we have three variables which is known and one unknown variable. According to this, the equation number 3 is most suitable to find out the time. So by putting the value here, S equal to minus 117.6 equal to the ut 49 into t minus half 9.8 t square, and this can be rearranged. This is 117.6 equal to, you can put this positive, 49 by 10 t square minus 49t. If you further simplify it, minus 490t, and this 10 multiply here also, so this is 1176 equal to 0. So this is a quadratic equation and we need to factorize it. So here first we take the common. If you take a common as a 49 from it, so take 49 common, so this will become t square minus 10t minus, if you multiply with 24 with 49, it becomes 1176 become 0. Okay, so that means you factorize it, t square minus 12t plus 2t minus 24 equal to 0, and you will get two factors here, t minus 12 and t plus 2. This is equal to 0. Since time is having only positive value, so t is equal to 12 seconds. So now let's check out the part number 3. What is the velocity and speed at the time when it hits the water? U is equal to 49 meter per second. The total time of flight is given by, we just measured it, 12 seconds, right? And A is equal to minus 9.8 meter per second. And we need to find out the velocity, the final velocity when it touches the water. So we have time of the flight, we have initial velocity, we need to find out the final velocity. So the equation number 1 is give you easily the value of v. So you just put the value, v is equal to, here u is 49 which is upward direction, minus 9.8 into t is 12 seconds. You can write down this 49 minus 98 divided by 10 into 12, and you can take out common 49, 1 minus 2 multiply 12 by 10, right? And this is 49, 1 minus 2.4. So this will be equal to 49 into minus 1.4, and if you multiply this, it will be minus 68.6 meter per second. So the velocity of the stone when it hitting the water will be 68.6 meter per second in downward direction. This negative sign shows the downward direction. And what is the speed at this time? So speed is a scalar quantity and it's always have positive value. So at that instant of time, the speed of that stone was 68.6 meter per second and velocity was minus 68.6 meter per second. So that is the only difference between velocity and speed. Now next part of this question, the how far will the stone travel just before hitting the water and what is the displacement? So how far it travels? So basically what happened in this case, a stone was thrown upward direction and then after reaching to maximum speed it came down and it fall into the water, right? So here the total distance covered by the stone is starting from here reaching to this point and coming back to this point. So this is the total distance covered or traveled by the stone, and the displacement, the difference between initial position and the final position. So let's find out the total distance traveled by the stone. Here in our first part, in this part we find out the maximum height attained by the stone. So that height was which we calculated was 122 0.5 meter. So that distance and that displacement here, it was calculated 122.5, and that was from here to here. Okay. And so the stone went 122.5 upward, then came 122.5 downward and reached to this point, and then further traveled this much distance, which is 117.6. So total is, if you add these up, it will come out 362.6 meter. So total distance traveled by the stone is 362.6 meters. Now what is the displacement? The next part of the question. What is the displacement? Displacement is this much, final location minus initial location. Okay, so initial location, if I take 0, because final location is in negative direction, so that is minus 117.6 minus 0. So the displacement is minus 117.6. Okay, so this is your displacement, and this is your total distance traveled. The key point here, that you have to first find out what are the information you have, what are the variables are known, then second thing, what variable you have to find out, and then according to that find out the suitable equation from equations of motion, and then put the values of these variable with sign. Remember the 4 variables which are vector quantities, so they need the value with sign. That's all we have for today's session. Now it is a time for 3 conceptual questions. Try these questions and write down your answers, doubts and comments in comment box. Answers to these questions are given in description box below here. I hope you would have enjoyed this session. And if you think you have learned something new today, then please click like button and subscribe us for similar type of easy to learn videos. Thank you for watching. See you next time. Bye.